Hello everyone. Today, I want to talk about the Alt+N menu in Blender, which contains the basic tools for manually editing normals. There are many ways to work with normals in Blender. Modifiers are often a powerful solution, but understanding the Alt+N menu is still important because it gives you direct control over your mesh normals. There will be situations where you have already applied your modifiers, but you still find some incorrect normal directions or shading issues. In those cases, making a quick manual adjustment can be much faster than rebuilding your modifier setup. To access the menu, first select an object and enter Edit mode, then press Alt+N. The first option is Flip. This simply reverses the direction of the selected face normals. However, when I use it here, the result might not be very obvious, depending on the shader applied to the model. On a larger or more complex model, you might not immediately notice that some faces have been flipped. To make this easier to see, we can enable some viewport options. One option is located in the Viewport Overlays menu called Face Orientation. This displays the orientation of the faces. Faces pointing in the opposite direction are shown in red, making it easier to spot flipped normals and potential shading issues. Another option is Back Face Culling, located in the Shading options. This makes the backside of faces invisible. This is also similar to the default behavior in many game engines, including Unreal Engine, and it can be useful when creating effects such as anime-style outlines. Below Flip, we have Recalculate Outside and Recalculate Inside. These options also change the direction of the normals, but they work differently from Flip. Instead of simply reversing the current direction, they recalculate the normals so they point either outside or inside the mesh volume. For example, if I select all faces and use Flip, every selected face will simply reverse from its current state. But Recalculate Outside and Inside try to determine the correct direction based on the surrounding geometry. This is useful when you have a dense mesh with some faces pointing the wrong way. However, if you already made manual edits to your normals, like in this example, recalculating can overwrite those adjustments. In that situation, using Flip is safer because it only reverses the current direction without recalculating the custom normal data. The next option is Set from Faces. This option is easier to understand on a model with bevels. Beveled meshes are a common starting point for creating good-looking hard surface models. However, bevels alone are not always enough. As we rotate around this model, we can see that the lighting does not behave correctly. The object appears softer than it should. This happens because the vertex normals are averaged between the surrounding faces. You can display these normals by going into Edit mode and enabling Display Custom Normals. The Set from Faces option allows us to manually control this. It forces the affected vertex normals to follow the selected face normals. So in this example, if I select every face except the bevel edges and use Set from Faces, the normals now follow the main surfaces. When we compare the original version with the edited version, the difference becomes clear. The original shading was incorrect, while the new version represents a much more accurate hard surface result. If you have edges that are marked as sharp, you can preserve them by enabling the option at the bottom left. Otherwise, the custom normals will ignore those sharp edges and create a smooth transition. As a quick note, if you have made several normal edits and your model starts looking strange, you can remove those edits. In the Object Data Properties under Geometry, you can clear the custom normal data. Alternatively, inside the Normal menu, you can reset the selected normal vectors. This will return them to the default behavior, where they are averaged from the surrounding faces. This only affects the selection, so the other custom normal edits on the mesh will remain unchanged. The next option is Rotate. This allows you to manually rotate the selected normals. There is no rotation gizmo for this tool. By default, the normals rotate freely based on your current view. However, you can lock the rotation axis using X, Y, or Z. You can also use Shift plus X, Y, or Z to rotate around the corresponding plane. Another option is to hold the middle mouse button and move over the rotation axis you want to use. The rotation axis orientation depends on the current transform orientation. For example, if I place the 3D cursor where I need it and use the cursor orientation, the rotation will now follow the direction of the cursor. You don't need to manually switch back to world orientation every time. Pressing the same axis key a second time will switch between the current orientation and the global axis. During rotation, you can press Ctrl to temporarily enable angle snapping. By default, Blender will snap the rotation in 5-degree increments. If you want snapping to be enabled by default, you can toggle it using Shift plus Tab. When snapping is already active, holding Ctrl will temporarily invert the behavior and allow a free rotation without snapping. Lastly, if you need more precision, holding Shift will slow down the rotation movement. The point to target option is a little more complex. When you activate it, pay attention to the options displayed at the bottom of the screen. Let's go through them. Use mouse. By pressing M, the selected normals will follow your mouse position on the screen. When you're satisfied with the result, confirm with Enter or a left click. Reset. If you press R during the operation, the normals will return to their original position. Invert. If you press I during the operation, the direction will be reversed. For example, instead of pointing toward the target, the normals will point in the opposite direction. Spherize. With this option enabled, the mouse position is treated more like a spherical projection. This can be useful for things like character hair or foliage. Align. The easiest way to understand this option is to look at the handles. Without a line, each normal points individually toward the target. When a line is enabled, the normals keep their relative offset and move together toward the target. Use pivot. This makes the normals target the selected pivot point. For this workflow, the 3D cursor is probably the most useful option. So if you place your 3D cursor somewhere in the scene and use this option, the selected normals will orient toward it. Other options, such as Align, can also work with this mode. Use Object. This uses the origin point of the mesh as the target. The origin is the small dot we can see on the object. If I move it and activate this option, the normals will point toward that origin. Set and use 3D cursor. As the name suggests, you can Control-click to place the cursor and immediately use it as the target. The final option allows you to use another selected mesh element as a target. You can select a vertex and Control-right-click another vertex to point the normals toward it. Now let's return to the normal menu and look at Merge and Split. If you have used Mark Sharp on edges before, you will notice a similar result. Both options affect how normals are shared between faces. If I select Geometry and use Split, Blender separates the normals between connected faces. This prevents the faces from sharing the same normal, creating a sharp shading transition. Also, it is actually marking the edges as sharp. The merge option does the opposite. It combines split normals back together, allowing the connected faces to share an average normal again. Next, we have the average options. The first one is custom normal. This averages the existing custom normal directions of the selected geometry. Each custom split normal contributes to the result. However, if there are sharp edges, it can ignore the split between them and merge the normals together, resulting in smoother shading. The next option is face area. This gives more influence to larger faces when calculating the average. In a way, this works like applying set from faces on a larger scale. You also have controls to adjust the strength of the influence. The last option is corner angle. It is similar to face area, but instead of weighting faces by their size, it uses the angles of the faces around each vertex. This can work better on curved or triangulated surfaces where face sizes are uneven. For example, on this cylinder, face area gives more influence to larger polygons. With corner angle, the weighting follows the angles around the surface more closely, which can produce smoother results. Maybe an easier way to understand it is looking at this shape. If I use the face area option, the biggest face has more influence because the weighting is based only on polygon size. With the corner angle option, the influence is based on the angles between the connected faces instead. Next, we have copy and paste vector. Let's say you have a vertex normal with the exact direction you want. You can select it and use copy vector. Then select the target vertices and use paste vector. The selected normals will now share the same direction. Smooth vectors blends the normals of selected vertices with the normals of the surrounding vertices. This can be very useful after manually editing normals. It helps create a smoother transition between edited areas. If the effect is not strong enough, you can increase the factor value or use the repeat option. The shortcut for repeat is Ctrl+R. The final two options will not have a visible effect unless you are using the weighted normal modifier. I plan to cover modifiers in another video, so I will leave this topic here for now. I hope this video helped you better understand Blender's manual normal editing tools. Normals can be a small detail, but they can have a huge impact on the final shading of a model. Thank you for watching.